In this session, we're going to look at the binomial theorem. We're going to explain everything that you need to know when it comes to binomial theorem, okay? Let's see. What is binomial theorem all about? In our previous lectures, we've seen the Pascal's triangle, okay? Now, we are looking at the binomial theorem. What did we learn in Pascal triangle? We said, starting with this, continue to say 1, this plus this is 2, then 1. Then you continue 1, this plus this is what? 3. This plus this is what? 3, then 1. Then you continue. 1, this plus this is 4, this plus this is 6, this plus this is 4, then 1. Okay? That is what we said is Pascal triangle. How was this useful? We said, for instance, if you are given x plus y raised to the power of 2, no need to waste your time. All you have to do is to simply follow this line. After 1, we have 2, and this is 2. That is the line we are going to use for the coefficients by writing 1, 2, and 1. That is this. Okay? Then we write this x, we write this y. We write this x, we write y. We write s, we write y. Okay? Then, looking at these 2, we said we put 2 here, we put 1 here, we put 0 here. That is from 2, we reduce, we reduce. Then for this, we put 0 for y, 1, then 2. For y, we increase from 0. For s, we decrease from 2. If you solve this out, this is s squared plus 2sy plus y raised to power 2. This was what we said was Pascal's triangle. That is, using this pattern. But what is binomial? Binomial is saying, what is the essence of wasting your time writing all this? All you have to do, I have discovered that there is a relationship between this coefficient and combination. Okay? He's saying, if you have something like this, the same thing, raised to the power of 2, instead of you, this is y, please, instead of writing the Pascal triangle, simply do start with this 2, say 2 combination 0. You know we have done combination in this channel. 2 combination 0, the first one. Then you take x, you take y. This s you take here, the power of this s is 2 minus 0. 2 minus 0. Then the power of y is this 0. He said you should continue. Say plus. You increase it now. You increase it. This remains constant. That is 2 again. Combination 1. From 0 to 1. Then you write s again. You write y. For this s, the power of the s is this 2 minus 1. 2 minus 1. Why the power of y is this 1. Okay? He said you should continue. Say plus. Again, 2 combination 2. This is where we stop. Because now we have 2 combination 2. This and this are equal. We have to stop here. Then you put s, you put y. For this s, the power is 2 minus 2. That is 2 minus 2. This 2 minus 2. For this y, the power is this 2. That is all. Now, he said you cannot work this out. If you work 2 combination 0, you agree with me, is 2 factorial over 2 minus 0 factorial, 0 factorial. Okay? Which is 2 factorial over this is 2 factorial over 0 factorial. 0 factorial is 1. Okay? That is to say this is 1. It means this cancel this is going to give us 1. Therefore, we are going to have 1 here. For this is s raised to power 2 minus 0, which is 2. What is y raised to power 0 is 1. 1 here. It means we can remove this 1. We can also remove this guy. Okay? To have s squared. Let's go for this one. 2 combination 1. That is for this. Which is equals to 2 factorial over 2 minus 1 factorial 1 factorial, okay? Which is 2 factorial over 1 factorial, 1 factorial. It means at the end of the day, we're going to have 2 factorial, which is 2 multiplied by 1 equals to 2. So this one is going to give us plus 2. Then we put s. This is 2 minus 1. 2 minus 1 is what? Is 1. What about y? Y raised to power 1 is also 1. Okay? Then we do 2 combination 2, which is 2 factorial over 2 minus 2 factorial, 2 factorial, which is equals to 2 factorial over 0 factorial, 2 factorial. 0 factorial will give us 1, that is 2 factorial over 1 multiplied by 2 factorial. This and this will cancel to have 1. It means we're going to put 1 here. This is s raised to power 2 minus 2, which is 0. S raised to power 0, y raised to power 2. What is s raised to power 0 is 1. It means therefore we're going to have y raised to power 2. Okay? So therefore we have s squared plus 2sy plus y squared. Okay? It means therefore what we are having here is what we also had in this place. Using Pascal triangle, we arrive here. Using the binomial theorem, we have this. So with this now, you can solve something like this. Raised to power 200. So therefore, if we have, say we have something like this now. A plus b raised to power n. This is simply equal to n combination 0, a raised to power n minus 0, this first a, n minus 0, then b is raised to power 0, plus n combination 1, the second one, then a and b. For the a, we say n minus 1, then b raised to power 1, plus we have n combination 2. A is n minus 2, b is 2. That is how you continue to do it until you arrive at n combination n. A raised to power n minus n, then b raised to power n. As you can see, we started from 0, 1, 2, continue till you get to this value. If 2 was here, we stop at 2. If 20 was here, we stop at 20. Okay? But this one, the power of this first guy is always this minus this, this minus this, this minus this, as you can see. Then this second guy, whatever I say, you put it for it. Whatever I say, you put it for it, and so on and so forth, as you can see. Whatever I say, you put it for this b. This is called what? The binomial theorem. Mathematically, how do you express this? This means addition, because you are adding so many terms. What is that? That is sigma. This means you are adding many terms, sigma. Starting from 0, because we started from 0. Okay? After 0, we have 1, 2, 3, 4. So all these terms, we are going to represent it by r. So r is starting from 0. Okay? We are going to add from 0 till we get to the end. What is the end? End is n. From 0 to n. If this was 20, from 0 to 20. If this was 10, from 0 to 10. So this n is representing the highest value. That is this n. Okay? Then the next thing is to get the coefficient. This combination. That is n combination r. This first guy is always a, n minus r. Yb is r. This is what? The general formula for binomial theorem. Starting from 0 to the last number, we are going to do for the first one, for instance, if 20 was here, we say 20 combination 0 for the first one. Then we say 20 minus 0. Then we put 0 here. The second one, the third one, the fourth one. The addition of all of them, that is what this guy is representing. Okay? Hope you understand this expression, because it's very good you understand mathematical expression. They will help you a lot. So this is called what? The binomial theorem.